Welcome course takers to section 2, outline of the application. In this video we're going to talk about the well-architected framework and why it's important. We're going to talk a little bit about how cloud is different from traditional data centers and what that does to the design criteria. And then we'll go into the detail around the 5 pillars that make up the well-architected framework. So it's unlikely you'll be asked specifically too much detail on the well-architected framework. But the reason for doing it is because it does influence a lot of the questions. And as we get into the detail, you'll begin to see some of the same themes we've talked about coming out. So what's different about cloud computing? Is it different? Well, these are drawn from the AWS Cloud Best Practices white paper that was updated in 2016, but it's still relevant, I think. So it talks about IT assets becoming programmable resources. Well, that's very true. Everything that you do in Amazon, you can do through the API. So it means that you can do things faster with less mistakes. Global, available, and unlimited capacity. Well, in comparison to your data center, absolutely. There are limits. And for large customers that I've worked with, there are definitely limits when you try and say to Amazon, when you want to deploy 50, 100, 200 instances in a particular region, sometimes they don't have the capacity. So if you're a big company, and you're doing lots of things with Amazon, it probably makes sense to do some forecasting and talk to them because they don't have infinite capacity. They will find you the capacity, but it can take a little bit of time. But for users like me doing this course, for example, I'm not going to run out of instances. Cloud has higher levels of managed service. This is a consistent pattern we see all the time where users of cloud use a lot more managed services to provide their application instead of building everything from scratch. And security built in. Yeah, security is definitely built in. You do have to use that security though. You can choose not to use it. So how does this change sort of traditional enterprise? Well, I've been doing architecture for quite a while. So why are we doing something, the contextual model? What are we going to do, the conceptual model? How we're going to do it, the logical model? And with what, the physical model, and TOGAF and Zachman and ITIL and COBIT. Now, all of these have a place. They all have a place in defining and creating the services that you're going to build in Amazon. No point building stuff that's going to cost you money if there's no business value. But the cloud architecture and well-architected framework is a bit more pragmatic than that. So it assumes that actually you want to distribute all of this into your squads, into your organization. You don't want to have a centralized organization that says, do this and you must do that. You do want to have an organization that understands that they need to stop guessing about their capacity needs. Instead, build something, test, validate it, look at the metrics coming back from CloudWatch or other performance tools and figure out actually what size do you need things to be. They do want an organization that can test their systems at production scale. This is really hard to do in an enterprise environment, because normally you just don't have the resources available to you. They do want an organization that can use automation to make technology experimentation, architectural experimentation easier, to say, well, what if we tried a NoSQL technology, or what if we tried machine learning? And that allows us to drive these evolutionary architectures that line up more with the business, that we figure out more things that we can do with technology to help the business, rather than getting caught up in just thinking about technology. Drive architecture using data, well, that has 2 parts. One is using data lakes and using big data to try to make decisions. But it also means around making sure that you test and validate all the thinking that you're doing, review the data that's coming back about your systems and infrastructure, and make some choices around that. And then finally, improve the way that you work through game days. So gamification, use scenarios, use tests to validate the things that you're doing. Because you can do that with cloud. You can build out big infrastructure, you can automate it, you can test and validate it all. So really think about these design principles when you're starting to think about how you build and design your application. And what that tends to translate into these kind of 10 areas really. So scalability, instead of scaling up, making bigger machines, scale out horizontally. That gives you challenges of how you manage state and distributed processing, but those are things that are good things to understand. And those are kind of the right approaches when you start building a cloud native application. Pets versus cattle is something that came from the US. So think of your servers rather than nice fluffy animals that you give them names. Think of them as cattle, and then don't worry about them too much. It's maybe not a great analogy, but it's used a lot in the cloud context. So basically, don't put too much stall in your servers. Be prepared to create new ones. If it's not working, don't investigate too much. Don't spend too much time investigating why. Simply destroy it and create it again using automation, which is the next box. So central to cloud is automation, and that's why it's probably in the middle. And we'll talk a lot about automation in other sections of this course, such as the CI/CD section. Using automation, automate everything. Use PaaS systems, use autoscaling, use OpsWork, use Lambda, use CloudFormation. Because we're creating scalable apps, because we don't want to care about our servers, because we're automating them, we want to have this concept of loose coupling. So if a single component fails, then you should be able to find another component to talk to use automatically through service discovery. Think about using asynchronous rather than synchronous connectivity. Think about graceful failure. And when you've done all of that, maybe you can use things like Chaos Monkey, which is a Netflix tool that goes around and arbitrarily stops parts of your infrastructure. Now, if you try to do that in most enterprises, I think your CIO, your chief architect, your CEO even might have a heart attack. Netflix chose to do that because they thought, well, infrastructure is going to be unreliable in the cloud, so we need to make the application more reliable. And so the way we do that is we destroy bits of our application estate, and then we troubleshoot it, we find it, and we fix it. This is a very mature approach to application development. I wouldn't advocate building your application and turning things off straight away. You need to spend a lot of time understanding how it works, but loose coupling is a very important part of any cloud-native development. So again, a point that comes through all the time, use managed services, things like identity as a service, Cognito, which we'll cover in this course. Build your own identity service. Down at the bottom, databases, well, use the right technology. Often in enterprises, you have to use Oracle or you have to use Microsoft. But actually, these days, it's probably more important to make the right decision choice, to use Oracle or to use Microsoft or to use DynamoDB or some other NoSQL database, depending on your requirements, not simply based on the fact that you have an enterprise license agreement with a vendor. All of these things allow you to build a better solution, and all of these things are available to you with cloud. No single point of failure, well, that's probably true for any application, if it's running in a data center or on the cloud. Optimizing costs, again, an important one. We've talked about this a couple of times now. Make sure you're sizing your instances to be the right size, not just the biggest size they can be. This is quite important. We'll cover some of this when we talk about Lambda, making sure we get the memory sizing right. Think about elasticity, scaling in and scaling back when you don't need it, and using things like reserve instance spot, both of which we'll cover when we talk about EC2. Caching, very important to manage state in a distributed system, so make sure that you can optimize your application estate. And finally, security, defense in depth. So make sure that every component you build has a security element. So these are general cloud design principles, and you can say that this kind of defines what a cloud native application is. And we'll talk a lot more about this. There are other frameworks that you can use, 12-factor apps and various other bits and pieces, but we'll talk about this and we'll talk about that more in the cloud native piece. But these are all the design criteria, the principles that you need to think about. So what the well-architected framework tries to do is bring all of that together in these 5 pillars. So operational excellence, how do you run and monitor your platform and your systems? Security, how do you protect it and deliver business value and manage risk? Reliability, very key, very central to everything. How do you build a system that can take known and unknown disruption and cope with it? Performance efficiency, not quite what you want. You might think by performance efficiency, but how do you evolve technology to meet the right requirements, as well as how do you manage the performance? And then cost optimization. How do you get the most amount of worth out of your dollar? How do you get the most amount of bang for your buck? Remember, you're being charged for everything. Everything is now visible. So cost optimization is a very important part of this. So the next part of the course will quickly run through these in more detail. Now, you won't probably need this level of detail for the exam, but as I said at the start, it really helps you understand some of the thinking around the questions. So, Amazon often talk about these principles and embed them into, and they help steer and choose an answer. So the answer is always there. It's a multi-choice exam. And if you think about the way well-architected framework works, then you begin to think about the way Amazon work and the way they layer their questions. So we'll not spend too much time. There's a lot of information in these slides, but I'll focus on the key points and the things that you need to kind of think about for the exam. So operational excellence. Okay, so anybody who's from an ops background, probably familiar with this kind of plan, do, check, act. This is kind of a general framework for ops. Amazon have their prepare, operate, and evolve framework. So the key tools really to think about CloudFormation, CloudWatch. So if it's a tooling question, normally it's around something around operational excellence. If it's about provisioning, it's CloudFormation. If it's around monitoring, it's CloudWatch. But things to think about in the question. So design principles, always think about infrastructure as code, codify things. Document. A lot of agile theory suggests working code over documentation, but it doesn't mean don't document. So here it's really about automating the creation of the documentation, using templates and using annotated documents that reflect the infrastructure, reflect what you're doing. So it is important. It's not the most important thing, but it is important that you do document everything and use, where you can, things like infrastructure as code to do that. Make small incremental changes. Well, absolutely, developers tend to do that. This is what the context of Agile is. Refine and keep refining, making operational playbooks. So how do you do this? How do you manage an issue? How do you troubleshoot? Make sure that you do have operational process and run books that are there to support you in cloud, because it is different if you're running it in Amazon to running it on your own data centers. Anticipate. So we talked a little bit about game days. So use game days to run events. What happens if you have a DR failure? What happens if you have an outage? How do you create this kind of application? And this all drives forward to learning from failures. Okay, so preparing, well, think about, what do your operations team want to get out of it? If you're the operations team and it's more of a DevOps structure, then how do you design workloads and applications to support that? So you can use things like CloudFormation to do provisioning, service catalog to hold static configurations or hold your service definitions, config to manage them, auto scaling, and SQS to do various bits of scaling out and decoupling. Operations, well, how do you monitor and manage it? So CloudWatch, obviously, you can use CloudTrail notification service. You can use X-Ray for Lambda, VPC flow logs, and various other bits and pieces for operations and for deploying code. And we'll cover some of these tools, particularly code commit, deploy, pipeline, and star. And we've already done some stuff around SDK and CLI in those modules. And how do we evolve our application? Well, CloudWatch is a very important technology, but you also see Elasticsearch, which is indexing technology, a very important part of an ELK stack, so Elasticsearch, Logstash, and Kibana, which provide a lot of visibility into your application, and Amazon have a managed Elasticsearch capability as well. Security, well, a constant theme, least privilege, and obviously the IAM tool, Identity Access Management, is the key tool. So STS, Security Token Service, we'll talk a little bit about as well. And then CloudTrail, CloudFront, Shield, Application Load Balancers, we'll cover all of those pieces of technology in subsequent sections and modules. So design principles, really around traceability, make sure you see and have visibility in everything you do. Defense in depth, apply security at all levels. Again, automation, constant theme here. Now, protecting data, very important, particularly in this GDPR world of the EU and UK at the moment. Make sure that you know where your data is and you know what type of data it is so you can control them. Isolation. On the whole, Try not to allow users access to data and to systems. Use proxies, use APIs, use the console, and then always make sure that you align and test your information management processes. So how do you deal with a breach? How do you make sure that people are putting data where they should and not where they shouldn't? Reliability, well, this is around monitoring and continuous feedback using CloudWatch. So a lot of things, any questions around reliability tend to involve monitoring. So design principles, make sure you test the failure in your recovery procedures. Again, you automate, scale out, not scale up. So scale out horizontally, stop guessing, monitor demand and utilization and size accordingly. That's a lot around, how do you stop guessing about the size of your platform, and then automate your change. So we've touched on automation at a technical sense now, automate your change management processes. So CloudWatch, that's the primary tool used for kind of reliability, but you have other things in there like Shield and VPCs. Then performance efficiency. So again, this is not really around performance monitoring. This is really around understanding how you use technology in the right way. So democratize your technology. So consume technology, but don't become the experts in it. And this is the thing that IT do all the time. They become experts, or they need to become experts in the latest and greatest enterprise service bus or database. But in reality, what we want to do is just consume that technology and not become experts in it. Scale out applications across the world. Well, Amazon allows you to do that. Try to think about serverless when you can. Forget about compute and storage. It's a much more abstracted design, and we'll talk a lot about Lambda in this course. Experiment, so don't be afraid to try something. And then finally, this polyglot view, choose the right technology for the solution. Don't just buy into what you have today. We're an Oracle shop, we're a SQL Server shop. Let's think about DynamoDB, let's think about Postgres, let's think about graph databases. And finally, cost optimization. We've discussed it before, we'll discuss it again. It's a critical part of any cloud architecture and design. Amazon is pay-as-you-go, so you can suddenly be presented with a very large bill if you don't manage your costs. So you need to be efficient, you need to monitor your costs, you need to think about moving away completely from your data center. But that gives you better total cost of ownership and potentially better return of investment. And again, use managed services. So you can see there are definite themes that come out around automation, using managed services, and cost optimization. So there's a couple of tools, Cost Explorer. You can use CloudWatch, as we've seen, to do billing events. You can use auto scaling, scale in and out. And then also there's lots of useful blogs from Amazon and from partner networks around how to manage costs, because it is a big area. Hopefully that gives you a good view of the well-architected framework.